And good evening. Welcome, everyone, to your Thursday evening dose of astronomy. I'm Irene Pease, and you're at the Amateur Astronomers Association site. Welcome, and thank you for joining us. You can find more about the Amateur Astronomers Association in New York City at aaa.org, and you can follow us on our social media channels at AAADOTORG. For this week, we have a couple of exciting things. We have Moontopia Part Trois. Last month, I should say, we had Moontopia Episode 4. Might just be a monthly thing through December. We're counting down to an exciting event and just highlighting some of the fabulous moons of our solar system. Note we went from 4 to 3. There's a reason because everything is backwards and upside down apparently in our world right now. And actually, the theme was retrograde. So we're going to get some kind of rebel moons in here. But just first off, I want to acknowledge the visuals that we have tonight. As usual, we have open space, which you can see in the background now. You can download that for free at openspaceproject.com, and we'll also be using Stellarium. I'll switch over to that in just a moment. You can find Stellarium, download that onto your devices or your desktop laptops at stellarium.org. So let's just jump on in and we'll check out the night sky before we zoom off to a couple moons in our solar system. So Stellarium shows us our sky as it appears now from Brooklyn. So not quite now. Sorry, this isn't updated. So let me just fix it. So there, that's now, now-ish, something like that. It's late. It's been a long week. So we're facing west. It's already dark and getting dark earlier. I guess until daylight savings, or I'm not gonna. So we have a lot of planetary stuff out. So that's kind of exciting. That's kind of why we're doing another Moontopia this week. If you look towards the southwest or the south tonight, actually, you can see the moon near Jupiter and Saturn. So every month we're going to do a Moontopia when the moon passes by Jupiter and Saturn because you have so many moons there. You have our moon. So just past new, we had a Lunar New Year. Happy Lunar New Year to everyone. Sorry, not a new lunar month, I should say. And then we also have all these moons around Jupiter and Saturn, and we'll be visiting a couple of those tonight. So again, Jupiter's moons, you can see, if I kind of center on Jupiter here, you can see Jupiter's moons in binoculars. And then with a telescope, you can see more detail. Sometimes you can see stripes. You can see the red spot on Jupiter is a fun treat. So all those moons strung out, the 4 largest ones. And then if we hop over to Saturn, in binoculars, you can see maybe just kind of make out the rings of Saturn or tell that it's kind of pinched like a lemon. And then in a telescope, you can see some of its largest moons and see the rings, all the labels blocking Saturn's rings here. So all the glory is Saturn from a telescope. So again, keep tracking those. They're going to be really fabulous all through the fall. It's officially fall, so I guess I should say happy autumn. Astronomical autumn is upon us. Mars is up. It's actually up getting earlier and earlier in the evening, and that's going to keep getting brighter. And I don't have to do like a big Mars shebang thing for the Mars close approach that's just in a couple weeks here. I realized I didn't really do a challenge last week, so I wanted to, put maybe another constellation out there for us to look for. So if you're going outside after sunset, there's this kind of boxy, kind of empty looking constellation in the west southwest. So it's kind of hovering above our horizon over here from Brooklyn. And if I turn on just a couple lines, this one here, so Ophiuchus, which is sometimes known as the 13th zodiacal constellation because the plane of the solar system, as seen from Earth, that line, the ecliptic, actually passes through kind of a corner of Ophiuchus, but we just kind of sweep that under the proverbial rug and ignore it and just pretend that that it's either in Sagittarius or Scorpius. But Ophiuchus is our serpent bearer. So if we look at the pretty pictures here, we can see there's a person holding a serpent. So the serpent is kind of an interesting constellation. It's actually two constellations. So it's Serpens Cauda, Serpens Caput. So either part of the serpent on either side of our serpent bearer. So that is also related to a symbol that a lot of people might be familiar with. So Ophiuchus holding the serpent is also related to that rod of Asclepius that people might be familiar with, like kind of medical symbol. So I just thought that seemed kind of like a nice thing to look for in the sky. With so many months into a global pandemic, there's so many people that are in our medical field that have been heroes and victims of 2020. So if you're looking up there, you can think of some of them. Hashtag Fauci, hashtag Breonna Taylor. So that kind of big boxy shape, if you look with binoculars or a telescope, you can actually see some really beautiful globular clusters, which I've raved about, but not recently. So let me just highlight those. A couple of really great globular clusters, M10 and M12 in Ophiuchus. So some brighter ones you can pick out. Even from Brooklyn, I've seen them in a telescope and maybe even binoculars if you can get to a darker site. So really nice clusters, big kind of boxy shape of Ophiuchus kind of setting towards the west this week. So see if you can pick that out. It'll be a nice challenge. It's, again, not one of the necessarily more well-known constellations, but it's up there and it's kind of in our evening sky. So more moons. Again, the theme was retrograde, and I realized that one of my moons isn't quite retrograde, but it's kind of like, we'll just call it inside out and missing or something. It's still kind of a rebel moon, rebel, something like that. So we'll pop over from Stellarium back to open space and take a little trip a little ways away from the Earth. Right. So open space, if you're not familiar with it, it's a wonderful platform. It's open source software, and you can download it, again, for free and use it to kind of fly around the universe in 3D. So we can load all this data in here. So what you're seeing in the background, those are actual stars. Those are where actual stars would be in the night sky if we were way out away from the Earth. There's these fuzzy spots. That's real. It's one of the Magellanic Clouds. The colors of the stars, those are, relatively, we get those as close as we can. And then all of the images of some of the moons that we'll see tonight, some of them I did load in because they're not as well known and not as well visited, not as much visited as some of the other moons, like our moon. So we're going to pop over towards Saturn first. We saw Saturn had a lot of moons. And we can see kind of the nest of them there. So if we turn on the planet orbits, we can see there's like a whole mess of moons. These are the orbits of some of the minor groups of moons. So you kind of get a sense of like how many moons these planets have. So this is like the nest of moons around, and I'm hearing the nest of moons around Jupiter, and then out past that, there's a whole another nest of moons around Saturn. And so we're going to skip over Jupiter for now. I think we'll do other Jovian moons at some other point. I don't think we did any for the last Moontopia. Can't even remember back that far. But yeah, here we have this whole swarm around Saturn. So Saturn actually has more moons than any other planet in our solar system that we know of. And I think part of that is just people have been able to go and mine the data from the Cassini-Huygens mission. So this was a ESA mission that spent several years around the orbit of Saturn, imaging Saturn, imaging some of its closer moons, and it did actually pick out a more distant moon that we'll stop by, but we're gonna head in and do my rebel moon, the one that's not actually retrograde, but it's still pretty interesting. So closer in, we see that the moons are kind of more in line with Saturn's orbit, so kind of in the same plane as the rings of Saturn. Um, and the moons that I want to visit first are some of these outer ones. So if you look at, I don't know how well you can see maybe the red markings. So these are some of the inner larger rings. So this larger one, this inner one is Titan. And then this other one that's kind of near it, it's just out past Titan, is I think that's the first one I wanted to visit, Hyperion. So we'll go ahead and focus in on Hyperion. So let's see what we have. So Hyperion is a little bit of a mess. This is one that some people call the sponge moon. As you'll see, so I have a couple different images of Hyperion just because its shape is it's so odd. It's so odd and so interesting, right? So as we come up on here, I tried to find a map to kind of put it like a skin, so to speak, on Hyperion here. So let me just do a quick edit. So we have some maps of Hyperion, again, thanks to the Cassini-Huygens mission. And in OpenSpace, we've tried to like wrap this map around this oblong thing. So it is oblong. It is not spherical. But just because, so I think this is great. It gives you like a nice perspective, and you can see like just how kind of blobby it is. But I do kind of want to show maybe just another image here. So this is this is another Hyperion image from NASA JPL. You can see it almost looks like a sponge. But the one thing that you don't get is like the perspective of this shape. So I did have to just click over to one other fun thing with Hyperion. I just went all out with Hyperion. All right. So this is another model. This is at solarsystem.nasa.gov. So this is a NASA visualization from their Technology Applications and Development Department. That's another like 3D model, and it has like the more of this shape. So I think I can drag it around, and you can see it's like it got hacked off or punched in or something. It's very potatoed, right? So we have the potatoey moons, and this is like a whole other level of potato. And it's not just that it looks like a sponge, it is actually textured like a sponge. So the average density is actually less than water, but most of the material making it up is like water ices. So that kind of tells us that it's very empty. Like almost half of it is just empty space. So this is your sponge moon, your rebel rubble, we'll call it, Hyperion, with its interesting orbit. It has a relatively highly eccentric orbit. It's again pretty far out. It's not as far out as some of those other lines that we'll be kind of delving out into momentarily, but it is kind of it is perturbed again by Titan's orbit. So having the moon Titan a bit closer, but relatively close to it, kind of tugs on it. So we have again, yeah. So you can see the orbit of Titan is relatively close to the orbit of of spongy little Hyperion. Um, so they have this relationship that kind of keeps Hyperion from getting into a more regular, more steady, or more circular orbit. And it's also kind of like tumbly. It doesn't really have like a regular rotation. So it's very chaotic. So even if we wanted to, we couldn't predict its orientation at any given moment. It's kind of all over the place. So that's kind of fun. So there's a little rubble, a bit of Saturn's system. So now we can get into the real rebels, all right? So the real backwards things. If we look just briefly again at Saturn itself. So if you look kind of down from the North Poles, down on the North Poles, then we see planets orbit the sun counterclockwise, and they also rotate in that direction. So let me just refocus on Saturn. And we can, I kind of move through time a little bit. So we can see these rotations. So we just rotate, I don't know, several hours. Yeah, you see everything zipping around counterclockwise. All right, so that's what we would consider prograde motion. And even if we zoom out, we see like some of the more distant satellites are still with prograde motion. So all the close-in ones have prograde orbiting Saturn in the same direction that it's rotating. But when we get way out, now they're kind of all over the place. One, they're not necessarily in that plane still. And two, we see some going in opposite directions. So we see some going clockwise and some out here going counterclockwise. So those are our those are our retrograde moons, kind of like orbiting backwards. So a lot of them are a bit smaller and probably just things that didn't actually form with the rest of the Saturnian system when it originally formed, but they've been captured in the few billion years since Saturn's been zipping around the solar system. So there's a lot of smaller solar system bodies that are out there that can get captured by some of the more massive giant planets. So this is probably one of them. We're going to go and visit kind of the outer part of the Saturnian ring system. So we're used to seeing the pretty rings of Saturn that I mentioned, like in close and personal and really pretty. I think I mentioned some of the names of the rings, and there was a moon that was like sweeping out the rings we talked about last time. But there's a relatively newly discovered ring. I don't want to say new, it's been there. We just didn't know about it. It's a little ways out here that we think is being caused by this other retrograde moon. So folks might be familiar back in, was it 2004? Not too long ago. We found this Phoebe ring. So the moon Phoebe, we're coming up on here, also very cratery, not spongy, but very cratery, more spherical, but still leaving maybe something to be desired. So we have a pretty full map. There's a little bit of data missing here and there. This is one of the best maps I found that were handy online. So you can see it's very heavily cratered. Yeah, so we think this may have actually been captured from way out in the Kuiper Belt. So it has a kind of a similar composition to some of the Kuiper Belt objects that we've been able to study in detail, like Pluto and its moons. And so we think that maybe this came in and kind of got pulled into Saturn's system, but it's such a light and fluffy thing. It seems to be like oozing debris all over the place. And those little bits of debris have formed a ring. So if we look for Saturn, where'd Saturn go? Saturn's way back there. So this is pretty far from Saturn. All right. So we're used to thinking of the rings as being like way in here, the bright, shiny rings. But there's this other ring that doesn't really show up in the visible because it's not bright and reflective, but it glows in the infrared part of the spectrum. So we can look with retrograde light and we can look with infrared light, and we detected this huge ring. It's actually very, very extensive. I'm not sure how massive it is because, again, very small particles, but it's very extensive. So Phoebe is out around 13 million kilometers from Saturn. And so the ring system kind of ends out there and then extends in towards Saturn to about a distance of 4 million. So between about 4 and 13 million kilometers from Saturn, there's this like long, thick ring of very, very small particles. So stuff that we think is coming off of Phoebe, so we're blaming Phoebe for this one, and then maybe getting pulled in closer to Saturn as it goes. So pretty interesting, kind of the cause of a ring. So that's not too bad for a very minor planetary body that, came in from out yonder and kind of got got captured. So in the background right now, sorry, I'm just checking a little bit of the comments. This is open space. So the software that we're seeing now is open space, which you can download at OpenSpace Project I'm going to mess it up, .com or .org, but I'll put it up again at the end. So yeah, so we have a lot of little moons like that. Not all of them create like a whole ring system, so that's pretty impressive. But I wanted to go ahead and move even further out, far, far out into the solar system. And so that's looking in towards that mess of moons in by Jupiter. And then we want to look more outward, just zoom way out to the cold, cold parts of the solar system. So the outer solar system is very spread out. Like if you look at the inner solar system, the terrestrial or rocky planets are all kind of crammed in here. Mercury, Venus, Earth, and Mars. There's a bunch of debris. Really, there's debris all over the place. It's a big, messy solar system. But then we have the gas giants, both of which have many, many moons. And then we have the ice giants out here, Uranus and Neptune, both of which have several moons, but not nearly as many as Jupiter and Saturn. So we're going to go all the way out to the most distant planet, Neptune, which is so far out there that it's only been visited by one satellite. So both Voyagers 1 and 2 stopped by both of the gas giants, but only Voyager 2 actually made the trip. It was just a good alignment. They planned this way in advance. It was an alignment, so Voyager 2 was able to stop by Uranus and Neptune, and we haven't been back since. So the New Horizons probe that went out past this region, it didn't actually stop by these planets. They were just in like a completely wrong part of the plane of the solar system, so did not visit those. But so we have Neptune in here. We can see kind of the swarm, a much smaller, less dense swarm of moons. Maybe, if we sent a probe there to orbit around Neptune, like we've sent to both Jupiter and Saturn, maybe we would discover more. And they're just too small and too far away for us to detect with our Earth-based telescopes. But let's just go ahead. I'm going to turn on time again so we can kind of get a sense of the directions that some of these are moving. And that's not fast enough. Let's go a little faster. Several hours per second. So yeah, so it's another fun thing we can do with open space. We can move through time. I mean, obviously we've kind of been doing some superluminal travel, getting all the way out to the outer solar system in less than 4 hours. That's not a thing you can do. In reality, it takes light almost 4 hours to reach Neptune from the sun. But yeah, I think we want to be pretty close in here. Trying to remember just how far out we're looking. That looks a little too fast. So a little slower. So we see some of the inner moons just zipping around Neptune. So it looks like we're kind of looking at the south pole of Neptune. I like to used to looking at the solar system a certain way. So I'm gonna turn this over. There's no up in space. It doesn't actually matter. Um, I just get less confused. Right. So here we see most of the inner moons going around it counterclockwise. So that's our prograde motion. And then we have a retrograde out here. So that one should be Neptune's largest moon, Triton. So when is a moon not a moon? When it's not a satellite, I guess. I don't know that they have like a lower limit on moons. I mean, some of the moons aren't even massive enough to pull themselves into spheres. So I guess as long as it's a natural satellite, we'll call it a moon until it, burns up in the atmosphere. Then it's a meteor. But let's go ahead and focus in on Triton. Triton, so not the largest moon in the solar system, but it's kind of the biggest, it's the smallest of the big moons, and it's definitely the biggest thing going around Neptune. So it makes up over 99% of the mass in orbit around Neptune. And we don't have quite a full map of it because it was just one flyby by Voyager 2 like 30 years ago. So it probably hasn't changed too much. But let me pause time and we can go ahead and get a feel for what all is there. So Triton, I mean, it's so far away. It would be a fantastic place to visit. And there have been proposals for missions to Triton. I think one that I thought had a really cute name was the Triton Hopper. And so Triton is, oh gosh, so many neat features. So it's covered with kind of like ice. It's icy, but it's mostly nitrogen ice. So Earth's atmosphere is mostly nitrogen, but on Triton, it's a couple hundred degrees below 0 Celsius. And so even nitrogen is frozen on its surface. And so we have the idea behind the Triton hopper would be this thing. It would be like a little self-propelled thing. It would kind of land and burrow in and gobble up some nitrogen and then use it to like blast off and land somewhere else on Triton, which would be really cute. But we're sending a quadricopter, whatever, to Mars. So that's kind of exciting. I mean, it's still very exciting, but it's, Triton. So it's hard to get stuff to the outer planets because they're just so far away. So far away. So one of the neat things, if you can zoom into some of the higher res parts of this, towards one of the poles, we can see kind of like these speckles. Because it's so cold, because it's very icy, it actually has a relatively smooth surface. So it doesn't have like the huge craters. It's certainly not spongy like Hyperion. It doesn't have the huge craters that Phoebe had. Nothing even close to like what our moon has. So it's been resurfacing frequently through cryovolcanism. So this is one of the solar system bodies that has cryovolcanism. Like we have volcanism on Earth, where we have like hot blasts of magma and ash and gases shooting out of our planet. So other solar system bodies, like Enceladus is one that has cryovolcanism, where it's shooting out like geysers of really cold material. And because it's lower gravity, these things go high into the sky, like 8 kilometers or more into the sky. And because there's a little bit of an atmosphere we can actually see evidence of prevailing winds on Triton. So some of the high resolution images show like these fields of geysers. So I have a feeling we're not quite getting it at this resolution, but if these little pinpoints were geysers, the prevailing winds blow that material, so the geysers all have shadows kind of going off in the same direction. So again, it's a very, very thin atmosphere, but it is an atmosphere enough that there are clouds. We caught an image just of a really thin cloud in the atmosphere of Triton. We think that there might be an ocean layer somewhere in there. There's so much more that we would love to know about Triton. So really cool features. It's, geologically active, which is pretty exciting. We always get excited when we see things similar to Earth, even though it's really far away, really cold. Never know what could be cooking there, and just what else we could learn about our solar system by studying all these diverse bodies. So we have a moon that's an astronomical body that orbits a planet or a minor planet. At what point do you call it dust? Yeah. So yeah, I think once it's broken up into a ring, so I think at some point one of Mars's moons is gonna get broken up. It's gonna get tidally pulled apart, and it'll become more of like a string, like a ring. But not Triton. So Triton's way out there. It's pretty solid. It's a rebel. And the other really important thing about Triton that we think it has in common with Phoebe is we believe it came from the Kuiper Belt. So we see similar composition to Triton, between Triton and Pluto. So really, Triton is bigger than Pluto. So if Triton hadn't gotten captured by Neptune, because again, Neptune's way out there, it's basically on the edge, the inner edge of the Kuiper Belt, and things that are out past Neptune we call TNOs, the trans-Neptunian objects. So it's past that really the Kuiper Belt gets super busy. So Triton, being retrograde, is most likely captured, and if it hadn't been captured, we would probably still be a dwarf planet out there in the Kuiper Belt, even bigger than Pluto. Take that, Pluto. So I think we've been retro enough, rebel enough for one evening. So I'm just gonna wrap this up. We'll just stay on the outer solar system. I don't really want to go back to Earth right now. But we'll put these credits up here. So thank you again for joining me. Thank you for checking us out for your Thursday evening dose of astronomy. Again, I'm Irene Pease here with the Amateur Astronomers Association. We're in New York City. You can find out other exciting things that are happening with the AAA at aaa.org. Check us out on our website. Check us out on social media. Follow us on the social media things. At AAADOTORG. And again, the visuals, if you want to do this kind of stuff at your house, like I am, you can download and run OpenSpace. It's at openspaceproject.com. And you can find Stellarium at stellarium.org. So again, thanks so much for joining us, and be safe.